Welcome to Future of Physics, number one physics forum in India, based for IIT JAM, Jest, GATE, DIFR, CSIR NET exam, and others MSc entrance exam. Today's discussion topic of electromagnetic theory, the overview portions of electromagnetic theory. The best important chapter and the best important part for TIFR, JEST, GATE, and IIT JAM. So now, electromagnetic theory, the sixth main part is normal incidence. Today's discussion topic. Normal incidence, I will discuss one best problem and solution. Next, oblique incidence, especially boundary condition. Especially boundary condition. Next, Fresnel's relation. Fourth, Brewster's angle. Five, critical angle. Six, the number of six problems. Reflection and transmission coefficient. Reflection and transmission coefficient. Now the first discussion topic about normal incidence, one best numerical. Now discussed normal incidence, a base numerical problem. Calculate the reflection coefficient for light at an air for light at an air to dielectric interface to dielectric interface mu1 equals to mu2 equals to mu0. Then n1 is equals to 1, n1 is equals to 1, n2 is equals to 1.5. At optical frequency omega is equals to at optical frequency omega equals to 4 into 10 to the power 15 seconds. Now its a solve point is reflection coefficient. Reflection coefficient is equals to R is equals to N1 minus N2, N1 minus N2 divided by N1 plus N2 whole square. Then is equals to 1 minus 1.5 and 1 plus 1.5 whole square. Is equals to 0.04 or 4%. 4%. Thus only 4% of light, thus only 4% of light is reflected and 96% is transmitted. Second part, oblique incidence. Oblique incidence is the part of in oblique incidence an incoming wave meets the boundary at an arbitrary angle theta 1. In oblique incidence, in oblique incidence, an incoming wave meets the boundary arbitrary at an arbitrary angle theta 1. Next, of course, normal incidence is really just a normal incidence really just a special case of oblique incidence. Special case of oblique incidence with theta 1 equals to 0. with theta 1 is equals to 0. Suppose that a monochromatic plane, suppose that a monochromatic plane suppose that a monochromatic plane wave of frequency omega, wave of frequency omega approaches the interface from the left, then approaches the interface from the left, then next we know that suppose that a monochromatic plane wave of frequency omega approaches the interface from the left, then K vector r, theta I angle, theta r angle, theta t angle, K vector t, K vector I, K vector r is the plane of incidence. Plane of incidence. Now approaches the interface from the left, then incident wave and the incident wave is this. EI vector of r vector t equals to E01 and vector of EI k1 dot r vector dot omega t v1 and r vector dot t 1 by lambda 1 equals to k1 into EI. And same as usual, the incident wave, reflected wave and transmitted wave, all three waves have the same frequency omega. The three wave numbers are related by the three wave numbers are related by omega is equals to k lambda as K1 omega 1 is to KR omega 1, sorry, or AT omega 2 or K1 equals to KR equals to omega 2 by omega 1 KT equals to N1 by N2 KT. And oblique incidence, the main part of boundary conditions. It is the main part of electromagnetic waves. Next, the combined field in medium. Follow the previous diagram. What is boundary conditions? The combined field in medium field in medium 1. Follow the diagram. Follow the previous diagram. E1 vector plus ER vector and B1 vector plus PR vector must join the field of fields of ET and PT in medium 2. Follow the previous diagram. Using the method is called boundary conditions. Using the method is called boundary conditions. Repeat. The combined field in medium 1, follow the previous diagram. E1 vector plus of ER vector and V1 vector plus of BR vector must join the fields of ET vector of and VT vector in medium 2. Follow the previous diagram. This is the called of using the method is called the boundary conditions. Next, the first law of plane of incidence. The incident reflected and transmitted wave vectors from a plane. The incident reflected and transmitted wave vectors from a plane called the plane of incidence, which also includes normal to the surface. The incident reflected and the transmitted wave vectors from a plane and called the plane of incidence, which also includes normal to the surface. Next, the second law, law of reflection, second law. Second law, law of reflection. The angle of incidence equal to the angle of reflection. The angle of incidence is equal to the angle of reflection. The mathematical form of theta I is equals to theta r. Third law or law of refraction or Snell's law. Sin theta t divided by sin theta I is equals to n1 by n2. Next, Fresnel's relation. Third topic. Fresnel's relation. It is called parallel and perpendicular polarization. It is the method of parallel and perpendicular polarization. Then case 1. Case 1. Polarization in the plane of incidence. Polarization in the plane of incidence. Applying boundary conditions, we get reflected and transmitted amplitudes. Applying boundary conditions, applying boundary conditions, applying boundary conditions, applying boundary conditions, we get reflected and transmitted amplitudes. Conditions, we get reflected and transmitted amplitudes. Applying boundary conditions, we get reflected and transmitted amplitudes. Next, applying boundary conditions, we get reflected and transmitted amplitudes is OR, E vector OR and alpha minus beta divided by alpha plus beta E0 T vector, and E0 T vector is equals to 2 by alpha plus beta E0 T vector. And next, where alpha where alpha is equals to cos theta t divided by cos theta I, where alpha is equals to cos theta t divided by cos theta I, and beta is equals to mu1 lambda 1 divided by mu2 lambda 2 is equals to mu1 into divided by mu2 n1. These are known as Fresnel's equation. These are known as Fresnel's equation. Notice that transmitted wave is always in phase. Notice that transmitted wave is always in phase with the incident one and the reflected wave in either in phase. If alpha greater than of beta or 180 degree out phase if alpha less than of beta, then the amplitudes of the transmitted and reflected, the amplitudes of the transmitted the amplitudes of the transmitted and reflected wave depend on the angle of incidence. On the angle of incidence, because alpha is a function of theta I, because alpha is a function of theta I, then alpha is equals to root over of 1 minus sine square theta t, 1 minus alpha is equals to 1 minus sine square theta t divided by cos theta t, cos theta I is equals to root over of 1 minus n1 divided by n2 square sin theta t divided by cos theta I. Repeat, if alpha greater than of beta or 180 degree outphase if alpha less than of beta, the amplitudes of the transmitted and reflected wave depend on the angle of incidence because alpha is a function of theta. Alpha is equals to root over of 1 minus sin square theta t divided by cos theta is equals to 1 root over of 1 minus n1 by n2 square sin theta t divided by cos theta I. Next, three topic, Brewster's angle, last three topics, critical angle and reflection and transmission coefficient. Then the first topic, Brewster's angle. Number of fourth point, Brewster's angle. At Brewster's angle theta b, at Brewster's angle theta b, reflected light is completely reflected light is completely extinguished when alpha is equals to beta. Extinguished when alpha is equals to beta. Sin square theta b, sin square theta b is equals to 1 minus beta square, 1 minus beta square divided by n1 by n2 square, n1 by n2 square minus beta square. Next, the special case of for non-magnetic medium. For non-magnetic medium. From non-magnetic medium, mu1 approximate of mu2 approximate of mu2. So beta is equals to n2 by n1. So beta is equal approximate of n2 by n1, and then sin square theta b, sin square theta b is equal approximate of beta square, approximate of beta square divided by 1 plus beta square, 1 plus beta square, and hence then tan theta b approximate of n2, tan theta b approximate of n2 by n1, n2 by n1, or theta t plus theta b, and theta t plus theta b is equals to 90 degree. Thus, at Brewster's angle, theta I is equals to theta b, theta I is equals to theta b, reflected and transmitted rays, reflected and transmitted rays are perpendicular to each other, are perpendicular to each other. Last, fifth topic, critical angle. Critical angle. What is the critical angle and our description of critical angle? When light enters from denser, when light enters from denser to redder medium, enters from denser to redder medium, n1 greater than of n2, n1 greater than of n2. Then after a critical angle theta c, then after a critical angle theta c, there is total internal reflection, there is total internal reflection, there is total internal reflection. Sin 90 degree by sin theta c, sin 90 degree by sin theta c is equals to n1 by n2. Sin theta c is equals to n2 by n1, at theta c, and theta t is equals to 90 degree. Theta t is equals to 90 degree. It is the all of the description about critical angle. Next, last number of 6 topics, reflection and transmission coefficient. The power per unit are tracking the interface is S vector and Z vector. Then thus the incident intensity is the incident intensity is thus the incident intensity is 1 is equals to half epsilon 1 v1 sorry 1 is equals to half of epsilon 1 lambda 1 the power per unit are tracking the interface is S vector Z vector and repeat thus the incident intensity is I1 is equals to half epsilon 1 lambda 1 is square ot and cos theta 1 while reflected and transmitted intensities are IR equals to half epsilon 1 lambda 1 square and IT equals to half epsilon 2 lambda 2 square ot and cos theta t. Next, the reflection coefficient R is equals to IR by IT equals to E0R divided by E0T and square is equals to alpha minus beta divided by alpha plus beta square. Next, transmission coefficient T is equals to IT divided by I small t is equals to epsilon 2 and lambda 2 divided by epsilon 1 divided by lambda 1. Then epsilon t divided by epsilon small t whole square and cos theta 2 divided by cos theta 1. Next, alpha beta into 2 by alpha plus beta square is equals to r plus t. Now then root of 1. If anyone feel of any doubt, then write your doubt and write your problem in comment box. Okay, thank you.